Please don't forget to like, subscribe, and comment. Thank you so much.
Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +234 808 509 5144 to learn more and get started today.
Okay, look at this. Look at what I'm writing. Look at what I'm writing. 3, 7, 11, 3, 7, 11, and so on. Let me write it properly. Maybe with a black pen, blue. 3, 7, 11. By the way, what do you think the next one should be? 3, 7, 11. What should the next one be? I need you to concentrate and stay quietly.
That's 16.
Are you sure? Check it properly. 3, 7.
Just 7 is 4.
So what should... Okay, did you say 15? 1, 5?
Yeah.
I thought I had 1, 6. Okay. 15, okay. Now, this is the first term. This is first. Second. Second. This is third. And this is fourth. So, with all the terms you have here, you can see that it has a particular pattern. How did you come about 15 from the third term?
You just added 4.
All right, we added 4. Now, whatever you were doing to get the next term, whatever you did to get the next term is what we call term to term rule. Term to term rule. So, term to term rule is what?
Term to term rule is when
What did you, for this particular question, what's the term to term rule? Whatever you did to get from one term to the next term.
add 4.
All right, so you added 4. Okay, so we can define term to term rule as what was done to move from one term to the next term. And what you did was you added 4. So the term to term rule is 4. So term, for that particular sequence, term to term rule is plus 4 or add 4. You know. Add 4 or add 4. Can I give you another one to before we talk about let's see position to term rule. Position to term rule. Are you ready for that?
Yeah.
Position to term rule. Position to term rule talks about how the position and the term are related. Like the first one is 3, the second one is 7, the third one is 11, the fourth one is 15. So how are they related?
Add 4.
No, that's different. What you are talking about is term to term rule. Let me put this in
Like
a...
all odd numbers.
Let me tell you how to get that. Let me show you. No, this is covering this. It's not okay. I will show you how to get position to term rule now. Just hold on. I want to put this in a box. Term to term rule. Remember what I said about term to term rule. Can you read it out? okay, what was done to move from one term to the next term? Like what was done to move from one term 3 to the next term 7, from 7 to the next term 11, from 11 to the next term 15. You know, you say you added 4, add 4, add 4. That's term to term rule, from term to another term. The position to term rule is about the rule that connects the position and the term. The position and the term. Like the first is 3, the second is 7, the third is 11, the fourth is 15. Now this is how to get that. This is the formula. There are many ways to do that, but I can show you this simple formula. You use this A. Okay, let me, position to term rule is this: A plus n minus 1 bracket, then multiply by D, where D is what you just got earlier, the common difference or term to term rule. But let me define each of them first of all. Pay attention, is very interesting. You will get that. So I said you need to define each of them. A is the first term. N is the nth term. That's the nth term, the term we're looking at. Or number of terms. Let me just call it number of terms. Number of terms. And D is what we call term to term rule or common difference. Term to term rule or common difference. So see the formula again. I'm going to put the formula in a box. Read out the formula. Read out the formula for term to term rule quickly.
A plus bracket n minus b. This is such a confusing way. There's such an easier way. This is so confusing.
Okay, you know another way to do that. I told you there are many ways. If it looks like you have another way to do that. Anyways, let's substitute and see how we come about this, and then you tell me the method you know.
Okay.
What for instance, this particular one we're looking at, this example, what's the first term? 3. Okay, so I think I will just zoom in and put those values. The first term is 3. The first term is 3 plus, you open a bracket, n minus 1, then times, what's the term to term rule?
What's done to move from one term to the next term?
Yeah, what's the term to term rule for this example we're looking at now?
Plus 4.
Plus 4. That means times 4. You know, because when this thing means n minus 1 times d. Do you understand? Maybe I should just put the times here so that you know what I mean. Times d. So this will be times 4. So read out what I have written here. 3 plus,
3 plus,
open the bracket, n minus 1, close the bracket, times 4. Remember, d is the term to term rule or common difference, which you said is 4. Okay, let's just go to the next page and simplify that. Okay, I need to create another one so that we can simplify it on that page. Go to the next page, let me simplify that. So this becomes, the term to term rule becomes, no, position to term rule. We said this is the position to term rule. We said it's going to be 3 plus, open a bracket, n minus 1, then times 4. let's open a bracket. Let's open a bracket in this expression. Are you ready? Are you ready? Now this becomes 3 plus this 4. You're going to use it to multiply whatever you have in the bracket. You're going to use it to multiply whatever you have in the bracket. Let's go. 4 times n gives us what? 4n minus 4 times 4 gives us 4. And that will eventually become 3 minus 4, then plus 4n. And what's 3 minus 4? That's minus 1.
Mr. John?
Yes, please.
Wait, actually, never mind. Carry on. I'll tell you after we finish.
Okay, this gives us 4n. What's 3 minus 1?
4. I mean,
3. What's 3 minus 4? Yes.
3 minus 4.
Mm-hmm.
Minus 1.
Minus 1. So, what would this whole expression become eventually?
Minus 1 plus 4n.
Yes, that's minus 1 plus 4n. Or you could simply say 4n minus 1 if you like. So this is the position to term rule. I want to quickly run through it to show you what I did. It's not difficult. There are many ways to do that. This is one of the simplest methods. But I want to quickly run through it. Go to the previous page. Let's run through it before we introduce any other one. Or you should tell me the one you know. First of all, you need to tell me, this is the sequence. By the way, this is the sequence we're looking at.
So usually the question would be like, work out the first 4 terms of the sequence with these nth terms.
Exactly.
So, like if you go to page 8,
Yes.
it will say find the nth terms for each of these sequences.
Exactly. That's what I'm talking about. In fact, we're going to use what I just did to practice some of these questions. Okay? All right. I love this. I love this. We use this as some of the questions.
Actually, wait. The method I know for one of these, for the method I'm talking about, the one that I said I find confusing, is the ones that look like this.
Okay.
So it says work out the first 4 times at the sequence with these nth terms.
Yeah, this one is easy. You just substitute values and then get those things. That one is easy now. It says work.
Yeah, so actually, I just realized.
Oh, this is what you know. You haven't learned this
No,
yet.
I haven't learned that
Oh,
yet.
okay. So this is the one you were talking about. I understand. This one is easy now. Anyway, since you're talking about this, we're going to look at it. But then let's go back to the page we're working on so that we can review this very quickly. Okay, go to the previous page again where we started, page 4. A very quick review, page 4. Yes. Now this is the sequence 3, 7, 11, 15, right? By the way, this particular sequence is called arithmetic sequence. Arithmetic. There are other types of sequence. And this formula is for arithmetic sequence. There's another formula for other types of sequence. Arithmetic is the one that has a common difference. I will tell you what I mean by that. That's common difference of term to term group, which is the same. From one term to another term, it is the same thing you are going to do. From the other term to the other term, the same thing you're going to do, and so on. Like from the first term to the second term, you added 4. Is it not? From the second term to the third term, you added 4. From the third term to the fourth term, you added 4. In all cases, it's always plus 4, plus 4, plus 4. So it has a common difference. And this is another way you can find the common difference. If you didn't know what to do, you could just say the second minus first. Can you do second minus first? 7 minus 3, what does it give you?
4.
4. So 7 minus 3 is still 4. Do third minus second, what does it give you? Do third minus second, what does it give you?
4.
4. So in all cases, you will always get 4. Also, fourth minus third will still give you 4. That's 15 minus 11. It has a common difference. Now that's term to term rule. Add 4, which of course is the common difference. Add 4 or plus 4. But the position to term rule, you need a formula. The formula is a plus n, open a bracket, n minus 1, close the bracket, times d. And I said a stands for what? Let's work faster. First term. N stands for number of terms, right? D stands for the term to term rule or the common difference. Okay, so like this question we just substituted. The first term is 3, isn't it? The common difference is times 4. That's positive 4 times 4. The common difference is plus, that's 4, which is D. So that's why so we wrote times the 4 times D times 4. And we simplified it here. 3, go to the next page.
Why is it times if it's a plus?
No, look at the formula. Read the formula again inside the box. Read the formula.
A plus bracket n minus 1 bracket times d.
Yes.
Oh.
So times d. That's why I said times 4. Did you get that? Times d. Did you get that? Okay, so go to the next page where we simplified it. So 3, which is the first term, plus, open a bracket, n minus 1, close the bracket, times d, which is 4. That's 3. Then you're going to use this 4 to open the bracket. 4 times n gives you 4n, isn't it? 4 times 1 gives you 4. So we now have this. So it becomes 3 plus 4n minus 4. And then you collected like terms 3 and minus 4. That gives 3 minus 4. And you know 3 minus 4 is minus 1 plus 4n. So this is the position to term rule. Minus 1 plus 4n or 4n minus 1. Did you see that? I need you to do this. Another example.
Wait, I have a question.
Go ahead.
Why did the 4 and the 4n switch?
No, it doesn't matter. You don't have to switch it. It's just another way of writing it. You know, if I wrote minus 1 plus 4n, you can write it as 4n minus 1. It's the same thing. And for instance, if you had minus 3 plus 5, it's the same thing as writing plus 5 minus 3. You get the same answer. I didn't switch anything. It's just a neater way of writing it. A neater way of writing it, okay? You will look at this one. Look at this. Look at this. What's the term to term rule here?
-3.
Minus 3. Okay, so term to term rule is minus 3. What we call common difference. So first of all, A is, what's A, the first term? 7. What's the common difference, which is term to term rule? Minus 3. Is it not?
3.
Or term to term rule. Now, to find the position to term rule, you remember what we do? The formula is A plus, open a bracket, n minus 1 times d. So let's go. Put those values again. 7 plus, open a bracket, n minus 1 times
and
Beautiful. Okay, so let's go. That gives us 7 plus. What is minus 3 times? What is minus 3 times n? That's minus 3n, isn't it? So times minus 3 plus minus 3n. And what is minus 3 times minus 1?
Minus 1.
No, minus 3 times minus 1. That's
minus 3.
Oh, what do you mean? Minus 3 times minus 1
Yeah.
plus 3. Remember?
Oh, plus 3, yeah.
Plus 3. So we have 7 plus minus 3 and plus 3. So let me go to the next page and write it. I need to create another box. So what's that again? 7 plus minus 3n plus 3. 7 plus minus 3n plus 3. Okay, so let's simplify this. I'm on the next page. What does it give us? You collect like terms. You have 7 plus 3, then minus 3n. Is it not? You know? By the way, plus minus is minus now. I don't have to. I hope you know. You know plus minus. Okay, let me write it better so that you see the same thing. This is 7 minus 3n plus 3. Because plus minus is minus. Is it not? Okay, so I hope you can see what I'm doing. Simplify now. Let's go.
Yeah. 4 minus 3n.
No?
Yeah.
How did you get 4? That's this is 7 plus 3. 7 plus 3.
Oh.
That's 10 minus 3, and is it not?
Oh. Oh. Yeah, 10 minus 3n.
Alright, so this is the term to term, position to term rule. I think what I would just do is to ask you to use this and practice this one here. We get the n term simply means position to term rule, okay? They're basically asking you, go to that last page, you see it. Position to term rule, that's what n term means. By the way, these ones that they're asking you to find the first 4 terms is easy now. Can we just do A? It's very easy to find the first 4 terms. So n plus 1, the first term will be 1 plus 1, is it not? The second term will be 2 plus 1. Yes. Third term will be 3 plus 1, is it not?
Yeah.
That's first, second.
It'll be 2, 3. It'll be 2, 3, 4, 5.
That will be 2, 3, 4, and so on. How about 2n? In fact, it's just substitution. Substitute n for 1, substitute n for 2, substitute n for 3, substitute n for 4, and so on. You get that? That's the same thing you do here. Substitute n for 1, substitute n for 2, substitute n for 3.
3, 5, 7, 13.
Yeah, and so on. So all is just substitution. You get, when n is equal to 1, what will it give you? When n is equal to 2, what will it give you? When n is equal to 3, what will it give you? When n is equal to 4, those are the terms. You know. So this one shouldn't be difficult. This is the one I want you to practice. Okay? So for each of these questions, let me zoom out, or zoom in rather. So work out the first 4 terms of the sequence with these nth terms. We've done a number of them. Let's look at this one. For instance, f 3n minus 2. The first 4 terms. F, for instance, it says 3n minus 2. 3n minus 2. So what we just need to do is to substitute for n. Say we should get the first 4 terms. So we substitute for n. When n is equal to 1, get the answer. When n equal to 2, when n equal to 3, and when n equal to 4. That's all we need to do. So for the first one, when n equal to 1, substitution. By the way, 3n means 3 times n. then minus 2. 3n means 3 times n, then minus 2. So we simply say 3 times 1 because n is 1. Then the answer minus 2. That will give us 3 minus 2 because 3 times 1 is 3. Then minus 2, that gives 1. The other one is 3 times 2, then minus 2, which is 6 minus 2, and that's 4. This one is 3 times 3, then minus 2, which is 9 minus 2, and that's 7. This is 3 times 4, then minus 2, and this is 12 minus 2, and that is 11. Am I right? 12 minus 2 is 10. Okay, so the first 4 terms are 1, 4, 7, and 10, and so on. So that's the way to do it. Let's look at J, for instance. J says 12 minus 2n. So J is 12 minus 2n. J is 12 minus 2n. So we also substitute when n is equal to 1, n equal to 1, n equal to 2, n equal to 3, and n equal to 4. So we just work out to get the terms. The first one will be 12 minus then 2 times 1, which is 12 minus 2, because 2 times 1 is 2, and that gives 10. The second one is 12 minus 2 times 2, which gives 12 minus 4, and that's 8. The next one is 12 minus 2 times 3, which is 12 minus 6, and that's 6. The other one is 12 minus 2 times 4, which is 12 minus 8, and that's 4. So the terms are 10, 8, 6, and 4. So these are the terms. For instance, if we are asked to find for example, if we are asked to find that's an example, e.g., find the 7th term. To find the 7th term, it means n is equal to 7, which simply means when n equal to 7. And we put that becomes 12 as n equal to 7. When n, we're going to have 12, substituting from here, that's 12 minus 2 times 7, 12 minus 2 times 7, and that's going to give us 12 minus 2 times 7 is 14. That will give us 12 minus 14, and that will give us minus 2. So any term, you just substitute that term for n. 7th term means n equal to 7. 5th term means n equal to 5, and so on. Let's look at more questions like this. It says these are patterns, or these patterns are made from sticks. Pattern 1, pattern 2, pattern 3. By the way, pattern 1 has 1, 2, 3 sticks. Pattern 1 has 3. Pattern 2 has 1, 2, 3, 4, 5 sticks. Pattern 3 has 1, 2, 3, 4, 5, 6, 7 sticks. So we can already see the order. Term to term rule is +2, +2, and so on. The common difference is 5 minus 3, which is +2, or 7 minus 5, which is +2. So 3 plus 2 will give us 5. 5 plus 2 will give us 7. So the term to term rule is plus 2. That means this next one we have plus 2, which is 9. And then another one we have 9 plus 2, 11, and so on. So we just draw it. Draw the pattern, the way it is. I can just copy this one and reproduce it here. So I will reproduce it here so that I can have the work. Let me zoom it in. Let me zoom out. So this is 1, 2, 3, 4, 5, 6, 7. So this one will be 1, 2, 3, 4, 5, 6, 7, then 8 and 9. So it's going to be like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. The next one will be 11, which will be 1, 2. So the next one is going to be like this. Let me paste it. This one is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, then 10 and 11. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's how it's going to be. Okay, now it says we've drawn the pattern 4 and pattern 5. It says how many sticks will there be in pattern 6? How many sticks will there be in pattern 6? We can actually get it. This is pattern 1, pattern 2, pattern 3, pattern 4, pattern 5. This is pattern 5. Obviously pattern 6 will be plus 2 again, because the term to term rule is plus 2. This is plus 5 plus 2 to give 7. That's 5 plus 2 to give 7. 7 plus 2 to give 9. 9 plus 2 to give 11. 11 plus 2 to give 13. So this one would have 13 sticks as pattern 6. Now another way we could have done it is to use to find the position to term rule. Remember, the formula is a plus n minus 1 bracket times d, where d is the term to term rule of common difference. The a is the first term, 3. So we have 3 plus, open the bracket, n minus 1 times d, which is 2. And that will give us 3 plus, open the bracket, there's no need to open the bracket again, 2n minus 2. That's 2 times n is 2n, and 2 times 2, or minus 2 times minus 2 is minus 2. So this will give us 3 minus 2 plus 2n, or 1 plus 2n, or if you like 2n plus 1 is the same thing. These two are the same. So this is the position to term rule. That's the position to term rule. Let me write it down. Position to term rule. is the position to term rule. This is the position to term rule, 2n plus 1 or 1 plus 2n. We can use this to get any term. For instance, it says how many sticks will be in pattern 6. For pattern 6, that's question C. If you wanted to solve C in a different way, what we would have done is, for C, for question C, which is pattern 6 means when n is equal to 6, we substitute n into this equation, that is still the same thing. So when n is equal to 6, we have 2 times n will now be 2 times 6, then minus 1, because it's 2n plus 1, 2 times 6 plus 1. It is 2n plus 1, so 2 times 6, when n is equal to 6, becomes 2 times 6, n plus 1, 2 times n plus 1. That will give us 2 times 6 is 12 plus 1, which gives us 13. And that's exactly what we got. It's the same value we are getting here. So any method can be used. It's the same value we are getting here. So when n is equal to 6 or pattern 6, we have 13, which we would have gotten by saying plus 2 to get 13, because the term to term rule is plus 2. So that can be done for that. Now this other question says, D, how many sticks would there be in pattern 10? We'll do the same thing. How many sticks would there be in pattern 10? Instead of counting up to 10, we just do for D, when n is equal to 10, how many sticks would there be in pattern 10? That's what the question says. How many sticks would there be in pattern 10? So we just do when n equal to 10. This gives us, this is the rule, 2n plus 1 will now give us 2 times 10, then plus 1. That gives us 20 plus 1, which gives us 21. So there will be 21 sticks. Then it says, which pattern we use 31 sticks? Which pattern we use 31 sticks? That's E. Which pattern we use 31 sticks? E. Which pattern we use 31 sticks? Which pattern we use 31 sticks? So it means the answer is already 31. So we simply say 31 equal to the formula. Remember, the formula is 2n plus 1. So 31 is equal to 2n plus 1. This one is a little trick, or let me write the formula first, and I say equal to 31. The formula is 2n plus 1, so it has to be equal to 31. But it says, which pattern has 31 sticks? So that means that formula has to be equal to 31. 2n plus 1 must be equal to 31. All we need to do is to solve this simple equation. So we simply do collect like terms. We have 2n equal to 31. This plus 1 crosses over and becomes minus 1. So 2n, we are solving the equation. 31 minus 1 is 30. We divide both sides by 2. So we're going to have 2n equal to 30, divide both sides by 2. We have over 2 over 2. So this gives us n equal to 30 over 2 gives us 15. So the answer is pattern 15. Is pattern 15 that will have 31 sticks. It says which pattern will use 31 sticks. So it should be pattern 15. I said write the formula. The formula or position to term rule, as position to term rule, which is the formula is 2n plus 1, and it is equal to 31. You solve the equation, 2n equal to plus 1 crosses over, it becomes 31 minus 1. 2n is equal to 30. You divide both sides by 2. So let me write it down here. Divide both sides by 2. That gives us this. So it's pattern 15. Now another question says, Theo says that he has made a pattern with exactly 100 sticks. Explain why Theo must be wrong. Well, it's obviously not possible to make 100 sticks. Let's see. That's F. To say 2n plus 1 equal to 100, because it says 100 sticks. 100 sticks. Theo says he made 100 sticks, so the total thing is 100, just like the total of this one was 30. So that formula equal to 100. The formula equal to 100, 2n plus 1 equal to 100. Let's solve it. So we're going to have 2n plus 1 crosses over to the right hand side, becomes 100 minus 1. So 2n is equal to 99. And when we divide both sides by 2, n will be equal to 48.49.5. Now it's given a point. We can't get a half or a fraction of a stick to complete the pattern. So Theo is wrong, because it doesn't give a whole number value. No, not a whole number. So it can't work because it's not a whole number. We need whole number sticks, one full, another full to complete the pattern. But the answer we're getting here is 44.5 when we divide both sides by 2. 2n is equal to 99. So 2n divided by 2, 99 divided by 2 will give us n equal to 49.5, which is not a whole number, so it can't work. It cannot work because it's not a whole number. So it can't work. Now that's the same thing we are asked to do here. It says continue the pattern to show pattern 4. The first pattern 1, 2, 3, 4. This one has 4. The second one 1, 2, 3, 4, 5, 6, 7. This has 7. The third one 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This has 10. So let's see the 10 to 10 rule. Plus 3, that's 4 plus 3 will give us 7. 7 plus 3 will give us 10. So the fourth pattern will be another plus 3, which will give us 13. This is the fourth one. We can draw that. How many dots will there be in pattern 6? We find the position to term rule like we did when we found the position to term rule in this first one, and then we do when n equal to 6, we get the answer. or we can keep writing until we get to 6. 4 plus 3 7 plus 3 10 plus 3 13 plus 3 16 plus 3 19 plus 3 21, and so on until we get to 6. Now it says, as this question is not complete, there are many other ones. This one says the diagram shows a sequence C. This one is 1. This is 1 2 3 4 5. This one is 5. As for pattern 2, pattern 3 is 1 2 3 4 5 6 7 8 9. This is 9. We can already see the term to term rule, plus 4 plus 4. So the next one will be plus 4, which will be 13. The next one will be 13. The next one plus 4 again, that will be 17. Plus 4 again, that will be 21. You know, 1 2 3 4 5 and so on. You know, but if we wanted to do it in a different way, we find the position to term rule using the same method we have used in the earlier words. We find the position to term rule, and then we say when n equal to that, we get the other answers. When n equal to 4, when n equal to 5, when n equal to 6, we get all their values. So, work out the number of circles in pattern 5. I think we already have it. Pattern 5, this is pattern 3, pattern 4, pattern 5, that will be 17. Or we use our formula when n equal to 5. After we have gotten the position to term rule, like we did here, we got the position to term rule, and then we said when n equal to this, we get our answer. When n equal to this, we get our answer. So it says work out the number of circles for 5. Write down the rule for continuing the patterns. I think it's plus the common difference, plus 4, and so on. Plus 4, that's 13. Plus 4, 17. Plus 4, 21. So plus 4 is the term to term rule. So write down a rule for continuing the patterns. That's what we've done. Then describe the rule for each of these. You know, describing the rule is term to term rule. 3 plus 2 will give you 5 plus 2, 7 plus 2, 9. The same thing here. 2 plus 2, 4 plus. Okay, this one is slightly different. 2 plus 2, you have 4. 4 plus 4, you have 8. 8 plus 8, you have 16. This one is 1. The next one, you add a 0. The next one, you add a 0. The next one, you add a 0. You know, there's a way we can always figure out the pattern. This is 15, 9, 3 minus 3. To find the common difference, you do second minus first, or third minus second, or fourth minus third. So let's find the common difference here, just as a guide. Second minus first, which is 15, no, which is 9 minus 15. It will be the same thing as saying third minus second, which will be 3 minus 9, or fourth minus third, which is minus 3 minus 3. That's this minus 3 minus then this 3. And if you look at all of them, 9 minus 15 is minus 6. 3 minus 9 is minus 6. Minus 3 minus 3 is minus 6. So whichever one we use, you will get the same common difference, which is D. So common difference is D, which we're going to use to get as many terms as possible. 15, 9, 3 minus 3. The next one will be minus 6. The next one will be minus 9. No, sorry, the term to term rule is minus 6. So minus 3, then minus 6. That will be minus 9. The next one will be minus 9 minus 6. That will be minus 15, and so on. So that's basically it. Okay, so look at this type. Read out the question first of all. Read out the question. Number 14, go on.
Here is the numbers. Here is the number sequence. Here is the number sequence. The rule for finding the next term to add a, where is an integer.
Then you have 8 dash, another dash, then 29. Then you ask to work out the two missing terms. It says here is a number sequence. The rule for finding the next term is to add a, where a is an integer. Are you listening?
Yes.
Now this is the way it is done. Like you have an idea. First of all, you say the last one minus the first one. 29 minus 8 gives what?
21.
21. Good. 21. But you need to be careful. You see, if there are two missing numbers, divide by 3. If there are 3 missing numbers, divide by 4. If there are 4 missing numbers, divide by 5. Did you hear that?
Yes.
How many missing numbers?
2.
So we are dividing by what?
2.
No, I said if there are 2 missing numbers, divide by 3.
Oh, there are 2 missing numbers. Divide by 3.
If there are 3 missing numbers, you divide by what?
4.
If you have 1 missing number, you divide by what?
2.
Good. If we have 5 missing numbers, you divide by what?
6.
Good. That's the thing. So that's just it. It's so easy. 2 missing numbers, divide by 3. So we have two missing numbers. 2 missing. So you divide by 3. That will help you to find it. 2 numbers are missing. Is it not?
Yes.
So if 2 numbers are missing, you divide by 3. Once you have a particular number missing, add 1 to it and divide by it. 2 missing, so we divide by 3. So what we're going to do is divide by 3. Let me make it bold. So divide by 3. Divide by 3. Divide by 3. Just add 1 to that and divide by it. So go ahead and divide 21 by 3. What will it give you?
21 divided by 3 is 7.
So you see it?
21 divided by 3 is 7.
So 21 divided by 3 will give you 7. You see that? So that's what will be added. 21 divided by 3 is 7.
For both of them.
Yes, 7. That means if you keep adding 7, you'll be getting the next answer. See, it's plus 7.
Oh, okay.
Plus 7, what will it give you?
Plus 7. 8 plus 7. 8 plus 7 equals 8 plus 7 equals
8 plus 7 is easy now.
oh sorry 8 plus 7 equals 15.
15. 8 plus 7 is 15. So the next one, you add 7 again. It's just that simple. Add 7 again. Plus 7.
15 plus 7 would equals 22.
Will be equal to 22. 15 plus 7 is 22. If you can even check the next one. Check if the next one is correct. 22 plus 7.
22 plus 7 would equals 29.
29. So can you see is correct.
Yes.
So that's the way you do it. Don't forget, if there are two missing numbers, you divide by what? 3.
You divide by 3.
If you had one missing number, you divide by.
One missing number, you divide by 2.
If you had 3 missing numbers, you divide by 4. I think that is clear.
Yes, that's clear.
So the answers are what and what? Answers are 15 and
15 and 22.
15 and 22. That's just a trick. I hope that's cool.
Yes.
All right.
Please don't forget to like, subscribe, and comment. Thank you so much.
Welcome to Like Learning School, your premier online education platform. At Like Learning School, we are dedicated to helping students and learners unlock their full potential, providing them with the foundation, support, and guidance they need for academic excellence. Our platform caters to two main target audiences. Firstly, we work with school children of all ages, offering academic follow-up and accountability partnerships. Our seasoned tutors provide personalized attention to ensure students stay on track and reach their goals. Secondly, we support students and learners who are preparing for internal, external, entrance, or professional examinations. We offer comprehensive and well-structured support to help them achieve outstanding performance in their exams. Our robust virtual courses are designed to keep students engaged and motivated. With interactive videos showcasing our teaching sessions, students actively participate in the learning process, making education enjoyable and effective. But that's not all. We believe in personalized education. Our students have access to personalized tutorial sessions, whether online, physical, or hybrid, tailored to their unique learning needs. Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +234 808 509 5144 to learn more and get started today.